Hello everyone, today we are going to discuss about the material aspects of solar panels. There are different type of material we used for solar panels manufacturing. So we are going to discuss about what are the different types and why we are using. If you look at this picture, we are usually using the polytype, polysilicon type, monosilicon type and half-cut solar panels and bifacial solar panel. A half-cut and bifacials are new addition to the solar industry. So let's look at one by one. So basically we have three different types, that monocrystalline and polycrystalline and thin film. So monocrystalline is a pure silicon and the efficiency of power production is 24.4% and the cost is moderate and longest lifespan. And the polycrystalline, that's an old type. So we are using a melted silicon crystal. The efficiency is low compared to the monocrystalline, that is a 19.9%. And least expensive, moderate lifespan. And the weight is 27.2 grams. Compared to the monocrystalline, weight is less. Then the last one is a thin frame. Thin frame is a new addition. It's like a seat. Solar panels is manufactured as a seat. This efficiency is low, like 18.9% compared to both other types. And expensive, shortest life and the weight is less. So different application. As you can see, different videos, there are some places we can easily install the thin flame seats. So we are using that. And basically, nowadays we are using a monocrystalline. This is advanced type. The monocrystalline we are using. If you look deeper into the mono and poly. Poly is the old before 10 years. Maybe probably whatever the installation we did before 10 years, we used monocrystalline. Now recent day we are using that we used polycrystalline 10 years before. Now we are using monocrystalline. So monocrystalline, by looking at both you can easily identify monocrystalline is look like a black color to make cell for monocrystalline panel. Silicon is formed into bar and cut into wafers. So this is how monocrystalline is fabricated. So if you look at clearly here you can see the monocrystalline structure and the polycrystalline. To make cells for polycrystalline panels, fragments of silicon are melted together to form wafers. So this is a old technology. Polycrystalline is an old technology and monocrystalline is a new technology and more efficient and having more lifespan. So next move into standard solar panel versus half-cut solar panel. So for last many years we have standard solar panels. In recent years, I think in last year only the half-cut solar panel technology introduced. So half-cut solar technology means like the standard panels we cut into half and we make more cells compared to the number of cells here. 1, 2, 3, 4, 5, 6, 7, 8 cells here. But here we have double 16 cells in one row. So this is in one column we have 16 cells. So the purpose of half-cut solar technology is to make the current carrying path easier. I mean in all old videos, in my videos you can see that what if anything one of the cell failed in this standard solar panel, the series here will not work. So the entire line of these cells will not work because of one single cell. So half solar panels help to create the path. So if you look at here that in the normal standard solar panels we have a path like it's going until here and come back like that. But in this half-cut solar panel what happening here? Current coming this path and continue until here, this point. And here it's joining again. So it coming back in here. So in case if one of the cell fail here, only this particular section is faulty, become faulty, not this section. So it means like we are reducing the risk of failing the entire series of cells into half. So in standard panel, if one of the cells fail, the entire series will fail. But here we are reducing in the half. So that's the reason. So half-cut solar cells are rectangular silicon solar cells with about half the area of the traditional square solar cell. Okay, the advantage of half-cut solar cells is that they exhibit less energy loss from resistance and heat. Because current carrying path is easy now. Because it's only to carry until this point. So it's like in a halfway, it can join here. The current can join after going through this path. It can come and join here. So this you can hear the current flow. This is a center path. It's shown here. This is the center path. So all the current will join in this path. So this is half-cut solar. This is a reason that the half-cut solar cells are more efficient. So increase total efficiency. There's a reason how the half-cut solar panels increase total efficiency. Okay, if you need to understand more, please go and watch my previous lectures about the solar cells, where I explain how the solar cells are connected in series to make a solar module. So if you understand that and compare, that is about standard solar panels. So then you can compare with standard solar panels and half-cut solar panel that we are studying now. So half-cut solar panel is a new technology. So it advances with 2 to 3% higher modular output because of this half-cut solar tech idea. This is a design idea. This is not much difference on the manufacturing. Of course, we have a slightly different because we have more number of cells we are using. But this is a design idea that having a half-cut solar module will increase the output efficiency and reduces the losses because the current carrying path is simplified. The current carrying path is simplified. There's a reason why we are getting more output. Okay, so this is the reason we are getting more output. Okay, next, you can see clearly that what is a full cell and a half cell. In half-cut solar panel, we are using half cell because we need to increase a double number of cells. So we are using half cells. So 2 to 3% power up. The efficiency is increased and less heat losses. Less heat losses. Okay. So next you can have a look on here. Polycrystalline, monocrystalline and half-cut technology and bifacial. We are going to study now about the bifacial. So the last thing is about bifacial. Bifacial means the solar panels facing both sides of the solar panels can generate electricity. In traditional solar panels, we have one side only can generate electricity. The bottom side is nothing, like the aluminum material is placed. Then we have the connectors and all other appliances, the bypass diode or other diode setups are behind the module. But this bifacial solar panels used both sides of the solar panel can produce electricity. This is another advantage or technology that improves the uses, that uses the reflected energy from the ground. If you look at the directional solar sunlight, this one on one light absorbing side, one side, okay. Light energy that cannot capture is reflected away. This is not the case with a bifacial solar panel. These types of panels have solar cells on both sides. Both sides. This enables the panel to absorb light from the back and the front. Back and the front. Practically speaking, this means that the bifacious solar can absorb light that is reflected off the ground. So basically, if your installation is a ground mounted, there's a clear distance from the ground, almost like a 1 meter or 2 meter distance. Okay, at least 1 or 2 meters distance. So what happened that whatever the solar radiation falling on the ground can reflect from the ground to the panel. So the bottom side of the panel can absorb this reflected solar radiation and can generate electricity. So it's mostly suitable for ground-mounted solar PVs. Because in case of roof-mounted, we don't give that much of a gap between the roof, your actual roof, house roof to the solar panels. We might leave only few inches gap, maximum of 1 feet, because it's for the airflow, the gap for the airflow. So that small gap, there's no reflected solar radiation can be achieved. So for the roof-mounted bifacial is not effective. But ground-bounded system, because ground-bounded system, we have used a huge land area where we place the solar panels in at least more than 1 to 2 meter height. Okay, at least 1 meter, more than 1 meter height. So that 1 meter distance we can use for reflect the solar radiation falling on the ground. Okay, so that's all for today. So we studied about 4 different things that monocrystalline, polycrystalline, and half-cut solar panels and the bifacial solar panel. So mono and poly there are 2 types. Polycrystalline, polysilicon we use olden days, early days. Now we are using the mono type. Then about the half-cut solar technology is a design concept like by improving the current carrying path we can increase efficiency, we can reduce the heat losses. Then the bifacial technology, bifacial solar panels comes through the idea of about how to capture the reflected solar radiation falling on the ground and reflected back to the panels. So we can use that as well. So thank you very much. Please subscribe this channel and give your support. Thanks for watching Ocentra Group informative videos. Please subscribe our channel for more informative videos.